So we call a set a collection is a set. Okay, is a set. Um, or let's say a set A is a collection of objects. Okay, set A is a collection of objects. These objects are called elements. Okay, A, for example, is an object of we call it elements. To show that A is inside A, we use this symbol. Okay, if it's not, we say that A doesn't belong to A, and we is not inside A. Uh, there is the empty set. We there is no that doesn't contain any element is a set called empty set. Empty set. So having sets, we can or make operations on the sets. We can regroup element objects of these elements. Then we have the union A union B. Is this set? It's a new set that is formed by elements that are objects or elements that are in A or X is in B. Okay, so let's do in parallel some examples here to illustrate all this okay concept. Okay, for example, here, uh, suppose that we have A is the set of with these three objects or three elements. B also has three elements, 2, 4, and 5. And C is another set that contains the only element 7. Then, if I want to form A union B, so A union B will be for me elements that are in A or elements that are in B. So elements that are in A are 1, 2, and 3. Now elements that are in B, there is 2, but I already put it here, so no need to repeat it. Then there is 4, 4 is in B, but it's not in A. So I need to include it in the whole set. So I will have then 4 and 5. Okay. Sometimes we illustrate this using a Venn diagram. So we say here is A, I set A, and here is B. And here, for example, they have a common point. Like here, we have 2. That is a common point. A union B is the whole. We need to get all the elements. We need to get them all. Okay? So this is the union. Now let's define what is the intersection, the common points. We call it intersection. So I will take all the elements that are together common, both in A and X in B. Okay, so if I want to illustrate this, I will have with using diagram, Venn diagram. Okay, so A and B, I will look the points that are common, that are in A and B simultaneously. That means I will consider only this part. Okay, for example, here, so A intersect B will be the only common element is 2. So I will consider 2. Okay, let's continue. There is also the complementary. We can define also the complementary. Uh, so the complementary of A, the complementary of A is the set, the elements that are not, that are in A, okay, or let's say A is in the bigger set U and X doesn't belong to A. So we complete by elements of the biggest space set. Let's say we have this set U and our A is inside. Okay, so the complementary will be will be this set, will be this part. This one will be the outside. Okay, this is the complementary of A. Okay, complementary. Let's say this one we said is the U, the biggest space. Okay. For example, here then the complementary of C would be yes, let's first define a biggest space. Let's say U or E instead U, maybe to avoid to mix it with the confusion of with union symbol. Let's put it E. Okay, let's put it the set E. So let's define a biggest set. For example, yes, I would like to take some. What about taking A union B union C? It is possible to do that. So I choose the operation. In fact, is we say it's associative. That means you can move when you do A union B. You have all, of course, we don't give everything here, but it's the same. The order is not important. Union B, union C, and yes. So you can even remove everything. So our set will be then 1, 2, 3, include 4, 5, and 7. Now, what is the complementary of C in uh, sometimes, yes, in the space E? Yes. So there is this notation also, complementary of A in the space E, complementary of C in the space E, okay, in the biggest set, okay. So it will be elements that are all elements that are in E and X doesn't belong to C. That means I will consider all the other elements 2, 3, 4, and 5 that complement C. Okay. What would yes, another important set. What about A product B? Product B. So this set is formed by couples, A pairs of elements, EB, where E is in a capital E the set, and B, the element B is in the set capital B. Okay. For example, if I yes, if I want to find A cross C, for example, A cross C, for me it will be elements that are pairs. The first component is in A, so I will have 1. The second component will be in C. C has only one element, so it will be 1, 7, then 2, 7, then 3, 7. Okay, and the order is important. Look, for example, C product B will be the first element will be 7, then 2, then 7, 4, and 7, 5. Okay, so this is how they are yes defined. Yes, we it is so this is we call it the product of E and B. So this one is the complementary. Okay, this is intersection, and this one is union. Okay, what about now? Yes, we can compare sets. Yes, there is a possibility to compare them using like there is an order. The order is more you will see it's more about, let's write the definition here. Complementary of EC, E inside E. Yeah. So those are the elements we defined. So just to organize things here, make it clear. This is an operation property of union. Yes, we have an order also. Order, but order of inclusion. We can say that A is included, a set is included in B if you can check that any element of A in the set A, then we have, then this element is in B. That means like here, A is included in E. Okay. What else? We have always, this is always true. A is included in itself. And also we have the transitivity or associativity. No, yes. And if you have, you know that B is included in C, then you can deduce that A is included in C. Okay. So for example, here I can see that I have, what about the intersection? E intersect C is empty. I can see that A intersect B is empty. Um, what else? A intersect C will be C. It's the smallest. What else? Now, or comparison, we can say, what else? We can say, see that C is included in E. C is not included in A. And C is not included in B. Okay, what else? We can combine, have to, yes, combine the signs, the intersection, then union C. So you have first a set, then another set, you take them. Okay, A intersect B, we found they have only, there is 2. Union C, which has 7. So the union, you need to keep all the elements, distinct elements. Okay, so this is how we can do. Yes, and there are other operations on sets, and those are the most important, I think.